Alrighty, so today we're going to talk about monitoring player load in American football. I'm going to talk about it from a very broad perspective and then narrow in, and we're going to talk a lot about different visual aids you can use and what perspective might be helpful for any particular situation. So a brief outline of what we're going to be discussing today is player load and what the definition of player load is, the science behind player load. So how do we come about making this metric and giving you this number, and what variables is it calculating in order to do so? The collection process, so we're able to talk about how is it getting it the number from a hardware standpoint. The application, so these are the different viewpoints we'll be discussing. We're looking at a team view on a graph, we're looking at a position view and an individual view, and what are the advantages and disadvantages of each, and what might you use in a particular situation. The last thing is going to be future application. So are you know, and I imagine a number of our clients already are, but for those who are new, the integration with the player load, but specifically with RPE, and how can we integrate those two together and complement each other very nicely, and then a conclusion and closing thoughts. So player load, the definition is represents the total amount of work we've done, and it gets that number essentially by looking at any way the unit moves, and it's in a 3-axis form. So we're able to see any type of forward movement, so front and back. Sideways is going to be the left and right, and up is going to be the vertical oscillation. So if you were to jump straight up, that's where it would pick it up. So we're able to see essentially this definition is telling us, hey, let's look at one number that tells us the total amount of work we've done within our 3 planes of movement. So it's essentially a total work completed metric. So the science behind it, and what really we devise and why we devised it, I guess, is if you have 2 athletes here who have a similar distance in terms of velocity. So you take 2 cornerbacks and they have the same distance overall in our run and sprint, but one has a lot more higher, sharper movements, and resulting in a higher player load. This could be due to that he's taking a larger number of reps, that he has a higher intensity coming into each rep than the other cornerback. That's where we would dive a little bit deeper, but essentially what it's showing here is, hey, if I have a guy who's got similar distance, but one's got a much higher player load, well, something's going on here, and that something is those short, sharp movements, and that's essentially what player load is able to pick up in the accumulation of that. So why is this important? Well, arguably his preparation and recovery would be different, right? It's, if you know the demands of a certain athlete are different from another, even if they're playing the same position and running within the same plays, they're going to require different preparation and recovery, and this is where the individualization model comes in, and that's a very powerful view that I'll discuss later. Player load, what it is basically an instantaneous rate of acceleration, and I'll show you this formula here shortly. And what we get from that, by dividing by a scaling factor, is this nice whole number, so we can see from a team view, let's say, where everybody stands in terms of this one metric. So this is, we'll focus on we'll talk about one here, the instantaneous player load. And like I mentioned before, it's accumulating your accelerations in your forward, sideways, and up with relation to the time you spend in those zones. So essentially what we're doing here, and it's looking at it, dividing it by a scaling factor. So we have, because if we didn't, we'd have numbers in the hundreds of thousands, and it wouldn't be a very nice number to work with. So essentially what we are able to see here is any movement we have in the forward plane, any side plane movement, and any upward plane movement, divide that by the scaling factor to give me a nice kind of number to work with. So we're within the hundreds, and now I can compare that within the athlete, within the team, within the position. Really, that's where the value comes into play. So the instantaneous is going to be calculating every hundredth of a second, really. So it's continuing to move up and down the scale based on what the demands are of that particular session, of that particular moment in time. The accumulated load is what variable we'll use a lot more, and that's telling us, hey, give me a total number on the period, on the session of what that player load was like for that athlete. And you'll notice here for time, since our unit is within 100 hertz, we're able to get 100 samples per second, essentially. So that gives us a very accurate representation of what that player load is going to be, because we are able to see small change of accelerations. So a little bit more about the science. This was developed by Catapult and the Australian Institute of Sport, and they wanted to develop a metric for measuring exertion level. And it was not dependent on distance. So if I were to run a mile, it would be correlated, but it would not be dependent upon my distance. It would be dependent upon the acceleration, not the velocity. So it's useful for sports like American football and rugby, because it's not running based. We're looking purely at acceleration. So we're looking at speed and how often that's changing, and tell me the accumulated player load for that session. So this just illustrates how they're correlated, but they're not dependent upon one another. So we have our nice odometer here and our accumulated player load, and you see both are going to climb the ladder as we continue to gain more yardage. We'll talk a little bit more later down the presentation, where how do we isolate how the intensity of a drill in relation to what's going on the field. So the collection is basically the hardware components of it. So the unit itself collects 1,000 data points per second. So there's a lot of information that this unit has to process. So we have a very smart processor on board to do that. And then we're able to get our GPS through the GLONASS system as well as the American system. So we're getting 3 constellations essentially of very accurate satellite reception to gain our GPS data, which is going to be our velocity data. The other internal sensors are going to be our gyroscope here, which measures our orientation of the body. So that's why if we come forward or go back or turn left or right, the gyroscope is going to be able to sense that. The accelerometer is the one that we use a lot for player load, and it's measuring impact forces. So we're talking about G forces here, and how high those are in relation to your speed, and looking at that from an accumulation standpoint. Magnetometers, it's going to measure, it's basically a kind of a compass inside, if you were. So or what direction are you headed, north, south, west, east. We have over 262 parameters within the S5, and we're able to gain a lot of information from that. So you can imagine that there's a lot of stuff we could discuss today. So focusing on essentially one metric with 2 subcomponents is going to be very effective with the use of time, just because there's so much great information we can collect. We want to be sure that we're we're being smart with our time and being impactful. So the application portion of it, obviously everybody's going to have a different system in place, and this is just one system. This is a system that I found very effective, and what view we're looking at, the date ranges, in the purpose of it, right? Why are we looking at a team view or positional view in certain situations? So we're going to discuss these 3 views pretty in depth, and the team is going to be talking about one particular day and why that could be important. The positional is going to be talking about over a week's time and why that would be better to view instead of looking at just the day or 3 weeks down the road. And then individual, which I think there's a lot of value within this. It is a time-consuming one to look at, but I think it's a very critical view because it's the recovery and demands are so individualized, and that's what PlayerLoad is able to tell you. So looking at it from an individual perspective is where a lot of the, in my opinion, a lot of this significant value lies. So let's start off with looking at it from a team perspective. We're going to look at just today's session, so one day, and the advantage of that is we're able to see a very holistic global view. So if we're talking about distance or player load in this case of who was my top 5 guys, who was my top 10 guys, we're able to quickly get that from there. And the disadvantage of that is it might not be capturing your significant variations within a position or especially within an individual. So if my player load guys, the top 5 guys, are always the same, and it's just because they normally do more work within their position, that's still important for me to know, but it shadows let's say I have a lineman who's working hard every day and he's within the middle of the pack, and then one day he comes up a couple positions in that ranking system. Is that significant or not? And looking at a positional or positional or individual view is that's going to tell you. So we'll jump into the player load application within a session and what we can gain from this chart here. So our step 1, or stage 1 rather, is volume management within total player load. What I mean by that is we're looking at it from one session overview of what we did on the day, what's our total work, what's our total volume, and we're breaking it up per period in a team perspective. So obviously we kind of chunked in period 1 to 7 here, and we're able to, that's the reason why this period is essentially so high. We could break it up in period 1, 2, 3, 4, 5, and so on, but we kind of broke it up in chunks here. But what we're able to gain from this is essentially see what demands are harder in practice, and you can see just the team and the big run in green zone being a pretty big chunk considering these are 1 period and 2 periods long. So the demand of those and the tempo of those are going to be drastically different, and not only is this average player load telling you that, but also looking at player load per yard. So how hard was the team working for each individual yard that they've covered? And you're going to find a lot of positional differences within this metric, and we'll discuss that later. But essentially it's saying, for the player load, tell me player load, this blue bar here, divided by the total distance that they've covered in that, and then we're going to map that over. So we're able to see these fluctuations, and that's essentially saying, what that is getting after is how many contacts were within that period, and how hard were they working for each yard. Another view you can have, so back here we had per period. Another view you can have is per athlete, right? So this can be a little visually overwhelming, but we're able to, kind of in that ranking system I talked about earlier, we could see the top 5 or 6 athletes and then our bottom 5 or 6 athletes. This could tell you a lot, and it could tell you very little. It depends on how much data we've kind of collected and what we can compare it to, right? If I know that, my bottom 5 guys are my rehab guys, and that's what I have set out to do, well, that's great. That's kind of just a check mark on the list, if you were, of, yeah, that we're in line, this makes sense to what we're doing here. And the top 5 or 6 athletes might be, well, we were actually supposed to hold back one of these guys, and we didn't essentially accomplish that. So being able to immediately flag it up through this perspective is an advantage. Now we're only able to look at 1 day's worth of information out of this perspective. So whether it's significant or not is really kind of the argument here of what does it really mean if we have our top 2 athletes here on the higher end. Is that normal for them? Is that an anomaly? That's where comparing it to multiple points of data is going to be worthwhile. So we're going to jump now into our positional overview. So before we were talking about team and looking at it from a session, and this positional overview is going to be more about the last 7 days. And again, these variables are never fixed, right? There's a system in place that can always adapt to the demands that we're throwing at it. So for me, the positional, looking at the last 7 days is very beneficial. So it's able to kind of be a middle layer of analysis, in my opinion, and we're able to look at differences within the positional groups. What I mean by this is what I normally do is compare wide receivers to wide receivers and cornerbacks to cornerbacks. But if I wanted to, I could compare the cornerbacks to wide receivers. Normally, I want to look at where those athletes as a position. So the wide receivers, where have they been in the last 7 days? Who's at the higher end in terms of total volume, total work done, and who's at that lower end? And why are those differences occurring? Is it's something we had planned for, or is it something that we need to make a modification in? So while it's showing us more context, the downside of it is it significant or not, right? Is it statistically significant? So that's where we're digging a third layer in, and we'll talk about the individual view of what has this athlete done last week versus today. And then what has he done not only within those 2 comparison points, what has he done the last 3 weeks, right? Where has he been in terms of recovery, in terms of the demand we've thrown at him, what the game has required if we're in season or if we're in fall camp. There's a lot of variables to consider. So player load, in terms of the positional, looking at just one particular session, just to highlight one of the differences here, is stage 2 is we're looking at more that player load per yard and player load per minute, and that is getting into player load per yard is essentially telling us it's a contact driven metric, right? So I'm essentially taking in total player load, my accumulated player load, divided by my total distance. So you'll find, and we'll discuss it, I'll show you in a graph visually later, of a lineman being much higher in this metric because it's contact based, while a wide receiver or skill guy, for that fact, of player load divided by my total duration of the session or the drill is going to be velocity driven, because it's picking up my contact times, my heel strike, a lot of vertical oscillation because of my high intensity running. Right, my high intensity running is going to be a lot higher in my skill guys than it is for my linemen. So this graph down here is essentially saying, based on one position, so the wide receivers, I have a couple different athletes here. Where do they rank in terms of a session difference? So I have one guy at 300 and another at 200, right? So it's 100 difference in terms of player load, and then top guy here is at 375. So there's a pretty wide range within there if I'm looking at one session only. This just allows me to isolate it, and I feel provides a better context when we're talking about kind of the ranges within player loads and what range is acceptable for your position, and the way you discover that is collecting information over time. So if I'm dealing with wide receivers and knowing athlete 7 is well below athlete 2, is that a common trend, or is that something that is not common, right? Is that significant? So looking at a week perspective, so the kind of jump back here, the difference in this visual aid here is we're able to see based on each athlete where they are in a given position, and this could be, for our example, it's a session, but this could be a week overview, and have it mapped out that way. For this, we're looking at everybody in that positional group and where they've been for each particular day. This, in my opinion, is very worthwhile. You're able to see where each session, you're basically able to see a nice periodization model of where we effectively tapering down before the game. So right now we're looking at camp data, so there's not going to be a game until the later end of camp, obviously. But if we're looking at in season, or just for example the first week here, we came in, had the hardest practice of any session for camp. Is that what we had set out to do, or is that did we want to build on that? Do we want to go from 70, 75%, work our way up, or do we want to kind of have this slow decline and then come back up a little through the week and then give them a little bit of time off and then hit them again, right? So we're able to gain very useful visual aids in terms of, are we getting after exactly what we want in terms of our periodization model. The advantage of using this player load metric is it's all objective, right? It's just calculating what it sees or what it feels, essentially. It's the g-forces of the unit itself. So I think this view is very helpful in terms of the player load, and then we're also looking at player load per yard, so we're able to see where that intensity metric is fluctuating. And if we're looking at a lineman, this would be an important one to observe based on the context. So you can see 813 and 821, our player load per yard were raised significantly, but our player load overall were pretty much down. So looking at that and saying, well, was that due to the session being more intense, short, and sharp? And we just had more contact drills, so digging a layer in there. And you'll find that often happens where you see these outliers, you see these outliers here and here, and then you need to dig a little bit deeper. But having these kind of overviews really helps identify what those are and where you can kind of go with it. So talking a little bit about positional differences now, kind of mentioned it, but people like to discuss, what metrics should I be looking at for my bigs versus my mids and skills. And since we're just talking about player load, looking at player load per yard, it's a very contact-driven metric. So in my opinion, you're going to be using that a lot for your linemen, and a good amount for your mids. It's going to be a heavily used metric for linemen. And then the next question is, well, what's a high number? That's a very subjective question. Obviously, we have different athletes and different different training programs, and that's where gaining kind of your pool of information is empowering, and understanding what those information points are. So for in kind of a general overview, I find that anything 0.12 and above tends to be a higher number in showing, especially for the bigs, it's showing there's a lot of contact in that particular drill or that particular session. For my skilled guys, looking from a velocity standpoint, what metric would I use? And it would be the player load per minute. So not looking at a contact, although this is an important variable to consider, not looking at it as heavily as player load per minute, just because this is going to tell me more or less, giving me a better indication of high intensity running and velocity and what that looks like in terms of intensity for my skill guys. I find that, and this is quite a broad range, but anywhere from 5 to 8, they were working pretty hard in that particular period or session. You're usually going to find that in a period. If they were working that hard in a session, that would probably be more short conditioning session than it would be a practice with that number. So this kind of just highlights the visual aid of why we used, or why I'm advocating using different metrics for different positions. And we have that blue line showing us what that player load per yard looks like, and you can see the O lineman versus the wide receiver, and how the wide receiver is a lot less than the O lineman in terms of this player load per yard. And like I said, this is heavily influenced to contacts, so we'd expect the offensive lineman to have a higher number here. And when we're looking at player load per minute, we'd have the flipped. We'd have pretty much a perfect inverse relation, right? So you have the wide receiver who's going to have more high intensity yardage and going to be able to run those 20, 30, 40 yard routes. That's where this number is going to come in a lot higher than the offensive linemen's. So you can kind of see that throughout the weeks in camp, and this is just really highlighting that player load per yard is very contact driven, and while player load per minute is very velocity driven. So the individual perspective. So let's dive into that. And a really important one is date ranges of how what do I look at the last 5 days, the last 7 days, the last 21 days. I find looking at the last 3 weeks is going to be very helpful. However, just keep in mind that the more and more you extend that range, the more and more data we have to view and consider. And I think we should consider, if we had a year's worth of data, we should consider a large portion of that year's worth. But within the short period of time, looking at the last 21 days is going to be very empowering to look at more of a longitudinal analysis of how is that athlete, and this is where the different kind of technologies come into play. And so I know objectively, player load wise, what the demand was placed on that athlete. Well, how has he been recovering? How have I been backing off him, or have I been backing off him? And is it significant to where he's been in the past 21 days? Like I said, the disadvantage of that is it can be a very time-consuming process, especially with a large group of athletes like football. So we have to be, if you have people who are full-time and are able to really look at the more in-depth analysis, then I would highly recommend that. Otherwise, we're going to be looking at the positional view more, with looking at a handful of guys within kind of the longitudinal analysis. It just really depends on the amount of time you can spend with the data.
Ooh.
So backing kind of all the way up and showing you the different perspective, what this is saying is there's one athlete here, and we're looking at one session. So we have first period, second period, third period, first OT. We're not going to gain a whole lot of information from that unless we're using a comparison of of where they've been. And that's kind of getting into the next chart of looking at more of a session overview of, okay, well, instead of breaking it up per period, what is it, where have they been in the last 21 days? So we're able to see, okay, well, it looks like we essentially gave them the day off here, and then we started to ramp up again, and we hit a peak here, and then we came back down. Did a very similar thing over on this side. So really being able to develop a individual periodization model off of that from a day standpoint, and the next step is a week standpoint, and then a month, and continue to go on, but able to see that objectively is, are we accomplishing that with this individual athlete? This is showing you the week overview of just totaling the player load. So we're able to see in the first week of camp, second, third, first in season, and so on. So we can see that the first week of camp, they were working pretty hard. If you're looking in terms of the second week of camp, it was approaching double the workload. So is that something we had prepared for, or was it something that it was not seen, and it was because one guy went down, and the guy in this information point had to step up and take double reps, or he was just working a lot more. He was coming out too early in pre-practice, and that's really, it's showing us very easily this, hey, is there an issue here, or was the rest of the team like this? Because that's a pretty significant difference in terms of almost double just within a week's difference. And then you go to the in-season, and this isn't showing us game information, which is, it would be nice to see, because we're able to, having that, we'd be able to adapt to those game demands, because that's what we're preparing the athlete for. So is this first week too much going into that, or did we kind of taper and back off enough where they felt fresh, they felt good in the performance of the game? The other metric I just put on here, and it's one to kind of look at and consider, is sum of player load 2D. So we're able to actually break up player load in any axes you want, if you want to go forward, sideways, or up. 2D is essentially looking at any type of forward or sideways movement without relation to up. So by doing that, we're getting rid of a lot of the data that's running data, is what it is. It's a lot of vertical oscillation. So we're able to see more of how often are you moving left, right, forward, back, and being able to get rid of the velocity information. It gives us a very clear indication of the time you spent kind of accelerating in relation to the total player load. So what proportion of that information is it? And there's not, I don't have an exact number for what that should be for that position or that individual. It's just a very, in my opinion, a unique metric to look at in relation to 2D player load with total player load. So the one that I really spend a lot of time on, and when I talk about what's significant or not, what's statistically significant, is this this view kind of here, is the z-score. This is going to tell you, based on a 0, my average, and we're looking at, if we just focus on the black line, total player load, am I 1 standard deviation above, or am I 1 standard deviation below? You can even tell it within half a standard deviation, but essentially, by kind of the statistical rule of thumb, anything above a standard deviation and anything below a standard deviation is considered significant. Is it plus or minus 33%? So your ranges obviously could be different. I sometimes like to work within half a standard deviation. It just gives a very crystal clear picture of where that athlete has been in terms of having a 0 average line for them, and are they above that in this particular session, or are they below that, and what's going on in context. Is this tapering off for a game, or is this because they're starting to see fatigue, right? So digging into that and understanding, am I overloading them and they're not adapting and they're starting to drop off, or is it because I've designed the practice to do exactly that? The last metric, in it's really kind of incorporating the RPE, is what, kind of what's the value in it, right? So we have our player load, and that's from the GPS unit itself, and it's giving us a very objective measure of what that athlete is doing. The advantage, in my opinion, is looking at our objective here, and then we have our subjective, our perceived exertion from the athlete. And for the most part, you'll see that if the athlete is filling out the logs consistently and accurately and honest, really, then you'll see that when it was an intense session, for the most part, their RPE, their load, is going to follow that pretty precisely. So you can see when the player load is higher, you'd see your RPE higher. The reason I like this is because if there's a disagreement, well, I want to know why. I want to know why, if this 700 load is here in terms of the GPS unit and he perceived it very low down here, right? Is it because that the intensity wasn't there, that he's recovered and adapted very well? It shows pretty clearly, like, okay, well, what's the difference here, and why is there a difference? And it basically starts asking, or lets you ask the questions and dig deeper into that level of analysis and looking at the data that way. So in conclusion, player loads are a really great metric to look at for volume and intensity. It helps develop our model for injury prevention. It's definitely a tool in the toolbox. It's by no means the only metric you should use, or the only tool you should use for that. The difference in views we kind of went over is going to be the team in our session overview, so looking at that kind of that daily overview, the position in a weekly overview of that last 7 days, and what's significance, what's not, and especially getting into the individual view of looking at z-scores and the last 21 days in terms of player load and what's going on with the athlete, where's he been, and where are we going with that? Are we going in season, or are we going into spring ball? Asking those questions and talking about the kind of the three different metrics here in terms of player load versus yardage, odometer. It's contact driven. Player load per minute is velocity driven, and who do we use that with? We use it, the player load for distance mostly for our line guys, and the player load per minute for our skill guys. And then also kind of diving into player load 2D, is it worth our time to start to explore that metric a little bit more, of looking at just the forward and sideway movements, and what other metrics do we overlay that with, and kind of getting into the RPE of, okay, well, why is it advantageous to look at my perceived versus measured, and if there's a disagreement, being able to physically just see that on a chart and dig deeper in your level of analysis. So thank you for your time. Really appreciate it. And if you have any questions, feel free to reach out through my email here. Be happy to answer any. And thank you again.